So first thing we did today was just to kind of review what we've kind of learned. So we know that mountains move. Mountains move on plates. Plates are big pieces of bedrock. Bedrock is broken up by faults. Faults are caused by earthquakes. Mountains can go up. Mountains can go down. Mountains can move across. Maybe some more stuff about earthquakes, just it's a breaking of rock. So lots of things we learned. So we just kind of discussed those really quick. Next, we can keep drawing models, but the models that we draw are not going to answer some of our questions. So next we're trying to figure out what happens when we have these mountains together. And so we're going to try to make a model, but we got to figure out what we're trying to make a model of. So we're going to show you that. So when we look at the plates on this map, we see that there's areas where plates push together. That's the yellow arrows. So this plate is moving into that one. So that's the yellow arrows. We have places where plates are moving apart. Those are the blue arrows. And then we've also got places where plates are kind of sliding past each other. And those are the pink ones. So first thing we did in class today was we looked at this map and we kind of found out what was happening at each type of a boundary, if you want to call it that. So when we looked at where yellow was pushing on something, so I'm just going to kind of look at all these here. So just kind of follow the cursor here. So there's one pushing, there's something pushing, there's something pushing. Notice that all those have mountains to the right of them. So all over here we've got mountains wherever a yellow is pushing in. So maybe it's just something with North and South America. Let's go someplace else. We got yellow pushing up, yellow pushing up, yellow pushing up. Above all of those, we have mountains. So that's kind of a pattern. Let's check out where blue is pulling apart. So blue is pulling apart here. And underneath here, we have an undersea mountain range. Okay, so that's kind of interesting. We got two mountains, or mountains forming in both when it's pushing and pulling. Let's check some other places. Over here we've got pulling apart, and you can see that there's mountains underneath. Not that you can see a mountain, but you can see that the texture is changing, and it's getting shallower, so it means it's higher. So we've got mountains where it's pulling apart. We've got mountains where it's pushing. Let's check out the pink. So here's pink, mountains, pink, mountains, pink, mountains, pink, mountains off to the side, pink over here, mountains over there, pink over here, and there's mountains there. So it looks like wherever we have plates moving, whether it's together, apart, or sliding past each other, they seem to be associated with mountains. Now, whether it's a correlation, just happens to be that way, or there's a causation that's being caused by something, so that's why it's always there, is something we have to find out. So that's where we want to go back to what we're talking about. So we want to see if we can model that. So what we want to try to do is we need to come up with a model that we can use in class. So we need to figure out what we want to model, what has to be in our model, meaning what's in the real world that we want to have in our model, and then how can we make that in our classroom so we can actually try something. So this kind of goes back to our weather unit where we use cold and hot water to represent cold and hot air. It's not the same, but they act close enough. So we're going to do the same thing here. So we need to have mountains. We need to have plates. We need to have the earth, because it has to be on something. Magma has been part of our models. There could be an earthquake. I'm just trying to think what else we had. I think that's what we came up with as a class. So that is the real world. Now I need to have our model. What could represent those things on our model in our classroom? Things we could get pretty easily to have here. So a lot of people were thinking the magma, it's like a liquid that could be water. People were saying, well, the magma's in the earth. It's not on the top layer. So the earth could be maybe the container that holds the water. People were saying plates could be something that would be on the water. So we had one class that we could use pieces of glass, like a plate glass that's just kind of flat. Maybe foam or something that stays up on top. Mountains could be rocks. And the earthquake, I don't think we ever figured out what we could use for an earthquake. So that was just kind of a question mark there, I guess. We didn't know what to do with that part. So that's what we came up with for an idea. What we actually ended up doing is this. So here we have our earth, our magma, the water. We have our plates, and we're going to explain the different types here. So we've got 2 pieces of styrofoam. So at one, we have 3 labs set up. So it's 3 different sections. One section has 2 styrofoam. One section has 1 styrofoam and 1 black foam. And our third station has 2 black foam. Okay. Now you're probably wondering why we have the black and white foam. So I'm going to go back. The reason why we have different foam is you can see that some of the plates are underneath the ocean. Some of the plates have land. If you remember our reading from a while back when we were talking about granite and basalt rock, basalt was more dense, and that because of that goes lower into the ground. So that's what the ocean floors are made of. That's basalt rock because it's more dense, goes deeper into the earth. The granite is lighter. Sorry, it's less dense. It's not light, it's very heavy. But the granite is less dense, so it actually comes up more to the surface. So the land is usually granite. So we had to show 2 different types of plates. So we have oceanic plates, we have continental plates. And that's how we're going to refer to those. Things that have continents are continental plates, or at least that part of it. And then also we have oceanic crust over here. So we're looking at those 2 types. So going back to our model, one of these is going to represent oceanic, and one's going to represent the continental. So we tested them, and the one that floats higher in the water is the styrofoam. So that's going to be our continental crust because it's going to be up on top. The one that kind of sinks a little bit more into the water is the black one. That's going to be our oceanic crust. And we're going to see what happens when we move these around just the way we described it in the map. We're either going to push them together, pull them apart, or slide them past each other. And that's going to be the video for the next class.